Section 8-4, Angles of Elevation and Depression. The objective of this lesson will be to solve problems involving angles of elevation and angles of depression. Okay, in this section we have two new vocabulary words. That would be the angle of elevation and the angle of depression. The angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. So for example here, the angle of elevation, this is the horizontal line and a line above that. So this right here is called the angle of elevation. And the angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. So this one right here. Here's your horizontal line and the line of sight below that. So that is your angle of depression. So since horizontal lines are parallel, angles 1 and angle 2 are congruent by the alternate interior angles theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. So if you remember, if these are parallel, this is your transversal. So angle 1 and angle 2 are congruent. All right, let's go ahead and start off with an example in identifying angles of elevation and angles of depression. So for first one, 1A, angle 5. If we look here, angle 5 is formed by this horizontal line and this line below the line of sight. So angle 5 would be an angle of depression. Next, 1B, which is angle 6. If we look here, angle 6, we have this horizontal line and a line of sight that's above it. So angle 6 would be an angle of elevation. Example 2. Suppose a plane is at an altitude of 3,500 feet and the angle of elevation from the airport to the plane is 29 degrees. What is the horizontal distance between the plane and the airport? Round your answer to the nearest foot. So let's go ahead and draw this and see what it looks like. We know that the plane is at an altitude of 3,500 feet. And the angle of elevation, so remember elevation is from the horizontal with a line of sight above it. This right here would be the 29 degrees. What is the horizontal distance between the plane and the airport? So this is your plane right here. And here's our airport. So they want this distance, the horizontal. Let's go ahead and remember our SOHCAHTOA so we can know which one we're going to use. I have here across the 29 degree angle, this is my opposite side. And the X side right here, this is my adjacent side. Okay, so we have an O and an A, so we're going to use tangent. So we're going to set up here. The tangent of 29 degrees is equal to 3,500 over x, the opposite over the adjacent. So whenever we have x in the denominator, we multiply both sides by that variable. So that cancels. And then to get x by himself, we'll divide by the tangent of 29. So the horizontal distance, if we go ahead and pull out our calculator, always remember to check your mode. We have 3,500 divided by the tangent of 29. So the distance from the airport to the airplane is 6,314 feet. All right, example 3. A forest ranger in a 90-foot observation tower sees a fire. The angle of depression to the fire is 3 degrees. What is the horizontal distance to this fire? So once again, let's go ahead and start off by drawing a picture of this first. We were told that a forest ranger is 90 feet above in an observation tower. So he's up here and he sees the fire over here. Let's say we have the trees here. All right, now since he's up here, his horizontal is right here. If you look straight out, he's looking down to the fire. So his angle of depression, because he's looking down, this right here is 3 degrees. Now, if you remember, we said that these horizontal lines, the parallel lines, and our transversal will help us find this angle down here of the triangle. So this is also 3 degrees. They want to know what is the horizontal distance to the fire. So this right there. Okay, once again, we're going to use our trig. We have to figure if we're going to use so, ka, or toa. So since this is my angle, this side right here is the opposite side, and this is the adjacent side. We're going to be using tangent. So tangent of 3 degrees is equal to 90 over x, the opposite over the adjacent. Okay, and I'm not going to show all the work here, but from the previous problem, we know if we have an x in the variable, we're just going to take our opposite side and divide it by the tangent of the angle. Okay, so we can put that in the calculator and see that 90 divided by the tangent of 3, that means that the Ranger is 1,717 feet away from the fire.